Okay, so this is an interesting integration by parts problem. Integration by parts, as you may know, memorize this formula. U dv, integral of that, equals uv minus the integral of v du, which is basically the product rule rearranged. As you know from Calculus 1, product rule is derivative uv equals derivative of u times v plus u times the derivative of v. That is just rearranged over here. And the integration by parts is good for taking two complicated, unrelated terms. If you can't do u substitution, say one is not the derivative of the other, you have to do integration by parts. And you might wonder, which do I choose for u dv? Well, there's a little mnemonic here, integration by parts, IBP, LIATE. It stands for a logarithmic, inverse trig, algebraic, trig, and exponential. And whichever of those terms appears first on this list, that's your u. So in this case, we have a trig and an exponential. So the trig appears first on the list, so that's our u. And we go down here and we have our u and in red, and our dv and our black. And from there, we find out the other two. What's the derivative of cosine omega t is negative omega sine omega t dt. And what's the integral of e to the negative st? Well, that's just negative 1 over s, e to the negative st. And we plug all that in up here. And these first two for u and v, that's just these two already taken, and we'll evaluate them in a little minute, in a little bit, minus the integral of these other two, the v and the du. And don't forget your dt. And that's our first integration by parts. So the first thing we want to do is evaluate these terms from 0 to infinity. And it's these two terms at infinity minus these two terms with t at 0. So for that, first we take the limit as t approaches infinity of cosine omega t, because you can't substitute infinity for t. They'll mark you down half a point or something for that. This is proper terminology. And that's just, you know that that's infinity. And the caveat was s is greater than 0, because with e to the negative st up here, that s and t are going to be in the denominator. So when t goes to infinity, that e goes to 0. And this becomes infinity times 0. Minus these two terms evaluated at 0. Cosine of 0 is 1. And this e to the 0 is 1, so you just get a negative 1 over s. And that's what we get when we come down here. We get a 1 over s minus, first thing you do when you evaluate these terms, you pull out the constants. Omega and s are just constants. So you have a negative 1 over s and a negative omega. It becomes a positive omega over s, and so you're minusing that. And you pull that out in front of the integral, and you're left with e to the negative st times sine omega t. And what do you get? What do you do with that? You have to do integration by parts again. So we bring it over here, and we have our u, our du, our dv, and our v, as we did before. And we plug them all back in to this thing over here. So we have 1 over s minus omega over s times this whole mess, which ends up being sine omega t for our u, times negative 1 over s, e to the negative st is our v. That's evaluated from 0 to infinity, minus the integral from 0 to infinity of our v du. And our v is negative 1 over s, e to the negative st. And our du is omega cosine omega t dt. Don't forget the dt. And so the first thing we want to do is evaluate this evaluation from 0 to infinity. And we go again, the limit as t approaches infinity of sine omega t. That's going to become infinity, and this with the t in the denominator, that becomes 0. So that sign is just going to bounce between -1 and +1 times 0. That becomes a 0, minus a sine of 0 is 0 times this, whatever it is, it's going to be 0. I just put a little xi in there. Didn't have enough room to write it all. And again, we pull out a omega over s, so that minus becomes a positive, at -1 over s. And from 0 to infinity of all this, and you say, wait a minute, that looks familiar, cosine omega t times e to the negative st dt. That's exactly what we started with. That's our capital F. That's Fred. So we can just, now we know what to do with this. Fred over here equals 1 over s minus omega over s times that omega over s times f, capital F, Fred. And as we know, the derivative of f of x equals capital F of x, or the integral of f of x equals capital F of x, and the derivative of capital F of x equals lowercase regular f of x. So that's what we're going to do over here. We have Fred equal to 1 over s minus w squared over s squared Fred. And the rest is just algebra. You subtract that term from both sides, and you factor out an f, and you have a special kind of 1 to get a common denominator, and then you divide both sides by that term, and that's what you're left with. And then this little s and one of these s squareds cancel out, and that's what you're left with. That's your final answer. Isn't that neat? So I hope you've enjoyed this little integration by parts. Try it yourself on your own. See if you come up with the same answers I did. I hope you had as much fun as I did. Thank you.